Hello, welcome to another session of the Houdini training. My name is Gianvito Serra, and today we're going to be looking at how to actually model a Greek/Roman column using surface operators. Okay, this particular exercise is meant to give us a little bit more familiarity of how to use the surface operator or SOP context inside of Houdini to create assets of a particular type. Very cool. So this is basically what we're going to be building, is a Greek style / Roman style column with the grooves and everything like that, as well as actually having like a top part and a bottom part. Alright? Similar to what we see here, with the exception that it is actually, we're not going to focus on the very ornate ones for the purposes of this tutorial. We're just going to focus on the simpler one, as right now we are just trying to get used to using some of the surface operators. And later tutorials we'll probably look into how to do the more ornate elements of the columns, but this will be probably a good start. Okay, so to begin our column, we need to first, as you can imagine, create a tube. Like I mentioned in some previous tutorials, to create a tube, simply hold Control while we click on the shelf, and that will create an actual tube inside of our scene. Okay? Very cool. Alright, so for my settings in the tube, I'm going to go ahead and give it a radius of 10 and a height of 100. So we're going to make it a nice tall column. In addition to this, we are going to also give it about 20 rows. Oh, not 220. And we'll probably go ahead and go with 24 columns for the time being. Okay? Awesome. Now, when you actually press the shelf button here, as mentioned before, you actually get an object which is added inside of a network view, which we can go ahead and actually inspect. If we go inside, we'll notice that in this particular network view we have an actual tube operator, okay, which is an operator which creates, as you can imagine, tubes. This particular operator is set to actually create polygons, as well as quadrilaterals and y-axis, and it has it has actually a particular center and a radius. You can see some of the parameters that we chose before show up here, such as the radius scale 10, the height of 100, 20 rows and 24 columns. Okay, we're also going to go ahead and give it just a little bit of a taper, so that we actually get so that we actually match a little bit of the taper that we have on the column. So something like 0.85 on the top, and then we leave it at 1 on the bottom. Okay, very cool. So looking at the columns that we have here in our reference, the first thing that we'll try to focus on is how to actually capture the actual grooves that we get inside of the columns. This is probably one of the most noticeable things inside of this particular type of architecture. So to do so, what we want to do in these kind of operations is a lot of times much simpler to work if you're actually working on just one slice of the geometry, as opposed to the whole tube that we have here. There is an operator which we can use called the carve operator, as in carving wood, which allows us to slice pieces of surfaces like this. Okay, so here is our carve operator. Now, you'll notice that the moment that we use a carve operator, something happened that we didn't expect. You look, there is actually all of these little points which are swimming on the surface, and nothing seems to be happening. The reason why is because the carve operator is an operator that operates on parametric surfaces and carves each primitive based on the u and v coordinates. Okay, in this particular case, because we're dealing with polygons, what it's actually doing is using the actual curves of the polygon as parametric surfaces. Okay, which is not what we would like to do right now. So what we're going to do, again, and this is one of the beauties about Houdini, it's never too late to go back and change something. We'll go back to our tube and switch it from polygons to nerves. Very cool. And our taper, everything is still intact as expected. So we can go back to our carve operation. And now you will notice that we can actually, indeed, carve around the U and V's of the actual primitive surface. Okay. So what we're going to do is to set up a first U as 0. We'll start here at the beginning, the very first area where the actual cylinders get seamed together. And for the second U, we will go to where we can at least grab about the first isoparm that we see here. So right about, oh, maybe just a little bit less. So right about here. Okay, beautiful. Next, we are going to need a groove to actually project inside of this particular hole. Okay. So if we look carefully at the actual shapes of the grooves, they're in essence basically a pill shape, which we can create very easily using some of the shape creation tools inside of Houdini. So let's go ahead and actually start creating a pill shape. So we'll start with a circle. So we press tab and we type circle. Okay. And we're gonna go ahead and make the circle the active node by clicking it. Okay. So here is our circle. And the thing to remember about some of these primitives is that by default they are an actual primitive type. So if we see with middle mouse here, you will notice that it is a circle type, which won't help us here. For this particular one, we want to actually use polygons. Okay, so here is our polygon circle. And we're going to also only do a semicircle. So we're going to go from the arc type, we're going to go to an open arc. And we're going to only go to about, and we're only going to go to like about half a circle. So that will be about 180. There we go. Next, we are going to offset our circle up to the height of a tube. So if you guys remember, the actual tube had a height of 100, and the circle is right in the middle. So in order for a circle to make it all the way to the top, we need to go to like about 50. So if we put a press tab, we can actually drop a transform node. Okay, and we can go ahead and highlight it. Remember too that we can also middle mouse on the actual tube itself, and we can actually see the tube what we're modifying here. No middle mouse, sorry, I meant click on here to actually bring in the template. So while that's there, we can move this all the way up. Okay, so this should really be like about 50. So we're just gonna go ahead and type it in right here on the parameter window. Very cool. Okay. Next, we're going to need a line which comes all the way down from here. Actually, I take that back. I don't need a half a circle, I need a quarter circle. Because if we look at the actual reference, it is pretty much symmetrical of all four ways. Okay, it is on the top as it is on the bottom, except for the taper. But we're going to take care of that in a different way. Okay? So the next thing that we need is a line connecting this circle to the actual button, okay, which is basically this line on the side of the groove. So we're going to go ahead and press tab and actually drop a line operator. Okay, and the most important thing about this line, and I'll go ahead and hide the tube right now, is that you can kind of see a little bit here, is that we need it to actually be offset a little bit to the left so that it aligns with the actual tube, okay, to the actual circle. Just to make that clear, if I bring the circle back down and we actually template it and bring the line here, we basically want to align with the actual with the side of the actual circle. So to do so, If our circle radius is 1, as you can imagine, the line just needs to be offset on the edge by 1. There we go. Cool. So now we can move our circle back up, and we can merge our circle and our line together. Very cool. So now we have a line here and a circle way up here. To attach them together, we can simply use a join operator, which is responsible for attaching curves together. There we go. So what this is actually doing now is that it's attaching the top to the actual is basically stretching the line so that it actually meets with the actual circle. Okay. Next, we're going to mirror this shape because we want it is actually mirrored. So we're going to drop a mirror operator, and we're going to get it mirrored on the left. Okay, so now you can see how we're actually getting close to that shape of a groove, which we have in this particular screenshot. Oops, scroll up. There we go. Okay, cool. In addition to mirroring on the top, we need to also mirror on the bottom. But before we do that, let's go ahead and press tab again and drop another join node to join the mirror and the regular together. Okay, so now if you actually look, we only have, by clicking here, you can see the number of primitives. We only have one primitive, which is what we should have. We'll go back to the mirror. You'll notice that we have the left one and the right one. Ultimately, we just want only one primitive for this part of the operation. Okay, very cool. Moving along, we're going to go ahead and mirror it again. So we do another mirror. Okay, but this time we're going to actually mirror it on the y-axis. Okay, so now we have our full groove, and just like we did before, we're going to click here, press tab, and drop another join node to actually join them together. Okay, so we have a single primitive, which is basically our groove shape, which we're going to have attached to the thing here, to the full shape. Very cool. Okay, in addition to doing that though, we also want to turn on wrap last to first so that our actual shape gets close together and it becomes a nice watertight little shape. Okay, cool. So we're moving along. What we need to do now is that we need to somehow get this particular groove shape that we have here into the little curved surface that we have here. Okay, so that we can have finally a piece of a tube that has a little groove on it. Okay, because this particular shape is a NURB surface or a parametric surface, it automatically comes with what is called implied UVs, where you have your U's that go from 0 to 1 and your V's that go from 0 to 1. Okay, given that, there is an operator which we can use which allows us to project curves based on that U and V mapping, almost as if the curves were basically a texture, if you will. Okay, and that is the project sub. Okay, so the project operator allows us to take any curve and project it into any surface as what is called a projection surface or a trim surface. Okay, so the way how we want to do it is that we want to connect on the left or faces to project, and on the right the curve that we're going to project into it, right? And you will notice that the first thing that happens is really not that much of anything, because by default the project sub works on along a vector. Okay, but what we want to do is to actually switch from along a vector to parametrically, and then map our coordinates, which is the x and y's, which is already mapped correctly actually, to the actual coordinates of the projection of here, okay? Very cool. So at this point, oh, I think I actually may have them backwards. Let me see. There we go. I apologize, I had them backwards. So there we go. So now we have basically our curve projected into the mesh. By the way, if you're wondering how I actually switch those so quickly, if you press any node while you have it selected, you hold Shift R, you can actually switch the inputs to try the different scenarios. Okay? Cool. Now we can actually, we can kind of see the actual shape here, but we can see it a lot better if we actually now use this shape to cut the surface itself. So we're going to put another node. This next operator which we're going to drop is going to be a trim operator. Okay. So the trim operator takes those projected surfaces, or those projected surfaces from the curve that I projected in the tube slice, and actually uses that to actually trim my patch so that I have, in this particular case, a nice little hole. You will notice though by looking at the hole that our groove is actually not quite as high as it should be. It actually comes to right about here when it really should come all the way down here. And that is because the UV mapping that we have for the V is a little bit different when dealing with because of the surface being so much taller than wider. Okay, so but we can actually come here while we have the node selected and click on the handle node to then get this little manipulator. We can use this little manipulator to simply grab this handle and pull our surface up and down. Okay. Now this is a little bit more like the way we want it. We can also switch the mapping to chord length, which will give us a little bit more of a rounder top right here versus the uniform. It's a little bit hard to tell there, but there we go. Cool. So now that we have this surface, we can now start. What we need to actually do this surface is to actually build the groove that is inside of this here. Okay. At this point in time, we are going to go ahead and actually save, and we will continue. Okay. So what we're going to do next is now convert this surface that we have here to polygons. At this point, we can actually start the operations that we're going to do are going to be probably easier to do as polygons than it is going to be as NURBS. Okay. Again, the beauty about Houdini is that it treats every single surface type as a first-class citizen. So you can very easily go back and forth in between being in NURBS and being in polygons. Okay. For this particular operation, because we're losing a little bit of shape here, what we want to switch is, instead of using level of detail, we're going to use divisions per span, okay, which is a little bit more specific to the kind of thing that we want to do. For the U and V, we're going to just go ahead and actually leave it at 0, which means basically we're going to generate a little poly slice, okay? But for the trim curve, we do actually want a lot of detail. We want to go all the way up, and if anything, we want to go all the way up to even higher than what the slider can, like 10, okay? So that gives us a little bit more fidelity on our actual shape. Okay? But yeah, we can play with this value if we wanted to try also different ways to map the actual trim curve. Now notice that the higher you go on the number here, the more points your trim curve is going to have on the actual curve, which may be ideal depending on how much detail you want there. Okay? You notice that there are just a few straggler points that were left from the actual conversion, probably points that had just a little bit of curvature to them, which actually were picked up by the conversion. You can clean those out very easily by using a facet F-A-C-E-T, and using the removing line points option. Okay, the removing line points options look at how much each point contributes to the actual profile or the actual shape, and the least they contribute, the more likely they are to get taken out. This particular one even stay around a little bit. We're just gonna go a little bit higher on the facet to see if we can actually make it go away. No, that one is a bit of a sturdy one. Let's see. We don't want to go too high because then we'll start actually losing detail on the actual curvature. So we'll go ahead and actually just stay with that. I don't think that will cause too much trouble. In fact, just doing some adjustments to the actual projection can potentially fix that situation. Maybe. No. Well, we'll move along. I don't think this will actually cause too much of a problem moving forward. We could probably get it resolved, of course, but you know, for the purposes of this tutorial, it's probably okay. Okay. So after we do this, we're going to go ahead and use a divide sub. And the divide sub allows us to do things such as triangulate meshes, but most importantly, it has a very useful operation which allows us to remove shared edges out of a polygon. Okay, so what this is going to do is that any edges that actually share faces are going to go away, leaving me only with border edges, such as this. The thing that is neat about that is that I basically get a shape in the center, which is what used to be my hole, now that is unbridged, as an actual curve. And if I come here, drop in a blast operator, we can actually get rid of the outer shape in favor of keeping the inner shape. Now an easy way to do that is that we can click on to show the primitive numbers, and we can see which primitive each one of these things is. Obviously the tall skinny one is primitive 1 and the one inside is primitive 0. Generally, when you do a divide sub, the inside curves are always going to be the ones that are going to be sorted the lowest than the outside curves. So in this particular case, it's a safe bet to say that I just want to keep polygon 0. And so basically I say now 1, 0, and then I say delete non-selected, and that leaves me with the actual curve. Okay, so we got a curve and we have the non-curve. All right, very cool. Next thing we're going to do is that we are going to extrude the shape inward so that we have a little bit of a groove to actually give the sense of the column groups receding in, like we see here. Okay, so let's go ahead and do that. So we're going to come out of here and drop in a poly extrude. Okay, cool. And we're going to actually go, let me hide the primitive numbers. Looks a little bit dirty now because we actually have polygons on top of polygons since we haven't given a extrusion value. But what we're going to do is that we're going to go inwards, actually the other way. I'm going to go inwards just a little bit, maybe less than that, like 0.25, probably like 0.33, there we go, 0.5. Okay, and also we're going to go give it just a little bit of an inset. Okay, an inset is just bringing some of those polygons inwards, so in that way we create a little bit of that group shape that we see in the actual reference. All right, very cool. So at this point we can actually merge the groove with the actual panel. So if we do a merge operator, we can do so. Now you will notice, if we look very closely at the merge operator, is that although it looks like it has only one input, the merge operator has 3 little arrows on its input, whereas the poly extrude has only one. When you see this, that means that this is a multi-input operator plug, and allows you, what it will do is that it allows you to put as many objects as you want into the merge. The reason for that is that on a merge operator you may want to merge like 5, 6, 7, 10 shapes. Another example of that is, for example, blend shapes. You know, you may want to actually be able to attach multiple blend shapes that way. But once we merge these two together, we're starting to get something that looks a little bit like what we want, which is great. Okay. All right. So next, we are going to go ahead and actually copy our grooves all across the column. Okay. So for that, we're going to use a copy, as in photocopy operator, which will allow us to do these copies. Okay. So just to talk a little bit about the copy SOP. The copy operator is an operator which allows you to do copies in many different ways of meshes. Okay. We're going to learn more about how the copy SOP works in some of the sessions in which we actually get really deep into instances. But just to show you really quick, if we actually come here and say that we want 6 copies and then translate to the left, you'll see that we ended up with multiple copies here. Okay. Now, what we would like to do instead of this is that we would like to rotate them around the center axis, okay, which we already have here. So what we want to do is come here and then start rotating them, and we can see that as we rotate them, they're actually starting to form the grooves around our column. Okay. Now you will notice that, so what we want to do is try to get very, very, very close here to where we want to be. Okay, so let's get really, really, really close. There we go. Doesn't have to be perfect for now, but this is just to kind of get us going here. Awesome. Then you'll notice that we need more copies. As you can imagine, we need as many copies as we need spans in the original tube. So if we go back to where the original tube was, we'll notice that we have, oops, that's not the tube. If we go back to where the tube is, we'll notice that we had 24 columns. Okay, so we need a few more to actually have the total copies. So if we go to the copy SOP and then keep going up, we can keep going around in a circle all the way up to 24. There we go. It looks like it looks quite 100% matching there, but we can actually go ahead and adjust things really quick so that they actually, there we go, so they're actually kind of touching. Very cool. We may need to adjust stuff on the very first curve that we also created just to make sure that things are actually lining up close. But this will be close enough for now for what we're trying to do. Okay. If we actually come here and take the wireframe out and just look at the shading, as you see, we're actually getting quite close to having what we actually want. Okay. Very cool. So next, we are going to go ahead and, now that we have our copies, we're going to clean things up a little bit. So let's start first by fusing all my slices so that when we come here, you will notice that they're a little bit split. For fixing that, we can use a fuse operator, as in fusion, and simply set the values to something like 0.01 in this particular case. Okay. Now you'll see that everything is attached, but now I also have some very harsh normals around my grooves because I'm fusing these very sharp edges together over here. Okay. We can simply fix that with a new operator in Houdini 14 called the normal operator, which allows us to create different types of normals. And in this case, what I like to do is that I like to create normals for the vertices, okay, so that the normals are not on the point, but they're on the verts, and I want their hard angle to be, you know, at about like 80 or so. So only really sharp angles are actually gonna get hard edges, like we see here. Okay. Okay. Well, we're actually really quite coming together now, which is really great. And so now at this point, we can actually probably move to the actual top and the bottom caps. Okay, if we look at the reference that we have here, you will notice that the caps are actually, they're almost like little outlines that we have here. Same thing for the bottom here. For the purposes of this class, I mean, we could actually build a system which looks at this image, analyzes it, and creates the actual caps for us based on this, silhouette, okay? But for the sake of this class, what we're going to do is just to actually draw the curve, that is the actual outline, and have Houdini take care of the revolving for us, okay? The way how we're going to do that is that we're going to come back to the very, very top. If you guys remember, we still have our NURBS tube that we first started with, okay? Which is great. What we can do here is that we can actually come out of a tube, okay, like as if we were starting over again, but we're not, because we can always very simply get back to where we were with the groups. But we can start at the very beginning of a tube, and we can go ahead and add, and go ahead and actually add another curve. Now this particular curve though, we're going to do something a little bit different, okay? Instead of actually taking a slice of the actual mesh, like we can do here, first of all, we're going to use the V, not the U, so we're going to go up and down. What we want to do is we're going to go all the way to the top, and then we want to, instead of actually cutting the mesh, we want to extract an actual isoparametric curve out of that location, okay? So you can see that we can actually even slide up and down the actual column to be able to choose where we want to actually start our location for our cap. Alright? Cool. Herefore, we'll leave this templated so we can see it. And the next thing we're going to do is that we're going to use an extrude operator. Now notice that there is a difference here. We're not using poly extrude this time. We're using extrude. The extrude is a little bit more like a shape lofter, if you will, whereas poly extrude is a little bit more like a poly modeler type of tool. Like poly extrude is what you will use if you were actually creating a character out of bots modeling. Extrude is what you will do if you wanted to make 3D fonts, 3D logos, using like, Bezier curves and things of the sort, okay? They're similar, but they have certain differences in how they operate, okay? Extrude has especially a very nifty feature, which I'll show you here in a second. But let me just go over some of the things that we have here, okay? So the first thing that you'll notice with the extrude is that we are going the wrong way. We're going actually inwards, okay? Right, because of the way how the curve gets carved, the primitive faces the opposite direction, okay? You can actually come here above the primitive numbers and display the primitive normals. We'll probably see that this one actually has the normal pointing downwards, okay? You can kind of see it a little bit on the actual segments here, but it's a little bit hard to see on my screen. But what we're going to do, so what we'll do is that what we want to do is actually go instead -1, which then makes us go upwards instead of downwards, okay? Cool. Next, what we like to do is to use a profile curve to actually create the shape that we see here, okay? For the purposes of this, I'm going to put this in a window on the right, okay? And I'm going to put this on a window on the left. There we go. So then that way we can look at our reference while we're doing this. Now, if you really wanted to, you could import these images inside of Houdini and do photo modeling right on top of it, and that's totally fine too. We have a means to do that using the display options of any of the viewports. But for now, we're just going to go ahead and just actually draw by hand to be able to move forward, okay? So we're gonna hit on the perspective button here and switch our view from perspective to front view. Okay, so now we can actually see the front view of this. And I'm going to turn on the grid because I'm going to need it as a construction plane. Okay. Now, what we want to do now, one thing that is neat about the extrude, like I was saying, is that you can actually feed it a curve and the second input right here, which is a cross section to extrude down into, okay? So what we can do here is that we can actually press tab and drop a curve, as in I should try to spell it right, curve SOP, there we go, and feed that into the right input of the extrude. Okay, so by default it's really not going to do too much of anything, but if we pick our, while we have the curve selected, if we pick our handle, now we're going to be able to do some really interesting things, right? So we can actually click here and actually start drawing the curve and see our piece of column come together interactively, which is really cool. Okay, so we can and then we're gonna go up here, there we go, maybe just about to here or so. Cool. And then we can go back over here and up some more. I'm not gonna get too caught up into this because I'm just kind of demonstrating what some of the things that we can do here. And this is the actual curvy part. We have one more here, and then up one more, and then here one more, and one more, and then one last one. Phew, that's a lot of steps. There we go. And we're gonna go like this, and that's it. So you'll notice that that was actually a very easy interactive way of building this particular shape right here. Okay, one of the beautiful things in Houdini is that everything that you do is pretty much fully interactive. So as you're actually building these things, you're gonna see everything coming together on the fly, which is very nice. It's very difficult to actually make mistakes as you're going through the process, because ultimately you see everything that you're doing, so you can actually catch yourself before you get too far into something. Likewise, like I said, it's never too late to change any of these things either. So if I wanted to, for example, edit this curve, I can simply drop in edit operator. Okay, and on the edit operator, I can simply go and start picking curve points. I can select multiple curve points, for example, and simply edit their shape to actually go ahead and modify the shape of my actual column. So say, for example, I wanted this to be a little bit higher. There we go. We'll pick these guys as well. We can simply grab these guys and then slide them a little bit higher. Okay. So again, it's never too late to change things, and never too late to fix things, because you're encouraged to actually keep all your history around, in this case in the shape of a small little node network. Okay, awesome. So once we have this one side, all that we have to do is to simply bring it down here and merge it with the rest of the actual column. There we go. It's looking really cool. In addition to this, we can actually go ahead and put the normal after the merge operation, so then that way the top of a column also gets the benefit of getting some of those clean normals. Okay, very cool. Now let's go to the bottom and let's do the bottom as well. So for the bottom, we are going to be able to do the same thing. One thing that is really cool though is that we can actually select all of these nodes right here and say Ctrl C and then hit Ctrl V, and that will actually paste all the nodes that we had selected to repeat that little bit of network. Okay, so now the tube is feeding into the main curve, this curve and this curve as well. All that we have to do now is just to simply change this to not go to the first V, but to go to the bottom V. And if we come here, check it out, the thing that we have on the top is now on the bottom. Okay, now if we look at the bottom, it's a little bit different than what we had on the top, so we do need to actually do some adjustments. So, but no big deal. That's because Houdini, like I said, is fully procedural. Therefore, it's never too late to change things as we need. Okay. So the first thing we want to do is that I do want to get rid of this edit operation, and I want to also make our curve actually start from scratch. Okay. And if we take a look at our extrusion again, now you'll notice that going to -1 is putting us actually back upwards, whereas going to 1 is actually moving us in the right direction, okay? So, while selecting the curve node, similar to how we did before, we can now also start drawing the bottom part of this curve. Now you'll notice though as I'm drawing that I am actually going upwards, which is not a good thing. Okay? The reason why is because, you gotta remember, because this thing is coming from the top now, we're actually dealing with this being completely upside down. Okay? So we can actually get it back by simply hitting reverse, but that actually doesn't fit it because, as you can see, now our actual curve is actually reversed here. Okay, so we don't want to really reverse the curve. We want the curve to stay as such. We just need to make sure that this is actually oriented the correct way. Okay, so perhaps what we need to do is to actually go back to -1 here. And now, if we look, there we go. Now we're actually fitting exactly the way we should. Awesome. So let's go ahead and actually continue this. If we come over here, we can probably just start from scratch. And then simply just start drawing and see your curve come together. Yeah, it's important to remember as we're working with primitives that sometimes, you know, the primitive orientation may not be what we expect, in which case we need to either reverse the primitive or reverse the operation so that that works. There is ways to also procedurally detect whether a primitive or a point or anything is actually oriented correctly, and you can use those to actually fix problems associated with that may be associated with with that in particular. So there is ways to always do these kind of things deterministically. The idea is that you won't have to expect a user to have to know how to do those things. You will be able to build things in such a way that they're smart enough to actually adapt themselves as the need arises. Okay. There we go. This is good. Okay. I think for this one I'm gonna just go ahead and keep it like that. And we're going to, like we did before, click on this and bring in the merge. Okay, so here is our whole thing together. And this is coming along just great. Alright, I'm pretty happy with the results so far. Okay, so this is looking great. Now, very typical in production though, when we think that things are looking great, changes come down the pipe, which require us to adjust things, okay? When we get to a state like this in a normal situation, such a change can be devastating. Say, for example, the art director came and said that, you know what, I don't want it to have 24 ridges, I want it to have maybe 12. Okay, so the thinking is that we can click on the tube operator, change this, and everything will work magically. Well, not quite. The problem is that when after you change this number, you do need to change also the curve operation, right? Because the curve operation depends on this number being the correct number, because it's trying to actually align against an edge loop like that. Okay. Likewise, the actual we can just go over here to the copy and simply add or remove copies, because we are depending on the number of spans to get the proper number of copies, and even the angle that we have here. So me coming in here and saying that I want 12 is just gonna leave a big gap hole here, and it's really not gonna change anything for me. Okay, just in the rotation is not gonna do anything, because things are actually, you know, more separated. Okay, so this is why it is very important when we build these systems that we build them with that kind of forward thinking in mind, and so that they are systems that are sound and allow for very quick changes laid down the pipeline. Okay, and that is one of the beauties about working inside of Houdini, is that, you know, it's never too late to do changes, but most importantly, it allows you to actually build this relationship in between geometries, so that they are aware of how each other change and adapt appropriately. Okay. So let's make it so that we can change make the art director happy and change the number of grooves anytime we want. Okay. So to do so, we're going to select on the tube operator. And you notice that what we basically want to be able to do is that we want the columns to be able to drive all of the grooves that we have in here. Okay. So to do so, we right click on the columns and say copy. And like I showed on the tutorial of making expressions, we can use this value now in different locations. So for example, we can actually apply that location to the copy operator. So paste, copy, relative references. Okay, so now my copies are gonna match the number of edge loops in my tube. Okay. Awesome. The other thing that we need to do is that we need to make sure that the carve operation is in sync with the number of grooves that we have here. Now for this one though, we need to remember is that a carve operation goes from 0 to 1. Okay. So in our case, we need this number to basically be a ratio of 21, where basically the actual slice needs to be the number of slices divided by 360, if you will, right? So basically in this case it will be a ratio of 1 divided by, we're gonna first, let's go ahead and copy the number of calls, which is gonna send this to 1, but then what we want to do is actually get 1 divided by that. Okay, so now you will notice that as I change my columns, I always end up with a properly sliced slice. Apologize, I was actually moving the rows there, I think, by mistake over the order. I mean to actually move the columns. But you can see it that no matter what I do, I always end up with a perfect curve that carves it right at the edge loop where it should be. Okay, you can see it right here even. Oops, that's the order that I keep messing with by mistake. There we go. Awesome. So let's leave it at 24, usually the way it was before. Okay, the other thing that we need to know is that the actual copy angle needs to be also a ratio of that number. Okay, so it needs to be basically the 360 divided by, or actually the number of slices divided by 360, or I think maybe the other way around actually, 360 divided by the number of slices. Okay, because basically for every, you're gonna have 360, which is your full circumference, and for every slice you're gonna have to rotate, basically have to rotate a segment of that 360. Okay, so what we do is that we first paste the value, which is gonna give us 24, and then we instead switch it to be 360 divided by 24. Awesome. So what that ensures is that no matter what we do, no matter how many slices we have, this thing will always be aligned, give you the exact rotation that you need so that the grooves align perfectly as you actually go around in a circle. Okay? It's really cool stuff that we can do here. So if we now look in here and go back to the actual tube itself, notice that as we move the columns, we now have the grooves expand and contract and perfectly match and tessellate with the actual space that we have here. Okay, so some really cool stuff that we have going on here. And this point, yeah, the art director has full say on what do they want to do. We can also, for example, control the actual height and drive the height of the actual location of a circle, which we know, if we remember, the circle is actually located at half the height, so that the actual groove appears where it needs to appear. So what we need to do is to actually copy the height of the actual column. Come back to the transform node after a circle and paste it here to get it in there. And then we want to divide it by 2 because we want it to actually be half of a circle. And lo and behold, now we have this thing perfectly aligned. So if I come here and I change the height of my column, you will notice that the grooves adapt perfectly without actually falling apart. See? Very cool. Beautiful thing about this is that we have barely done any scripting. It's one of the things that I love about this application is you barely ever get into the scripting inside of it, and when you do, it's very little stuff. So it's really neat in regards to this, how this application actually works. You can even add more rows in this particular area if we wanted to actually add a little more detail there. And our taper that we added at the beginning is still available to operate, so that we can actually get a little bit more of a taper on this, and everything still works, which is great. Very cool. Actually, just to demonstrate even the taper with the actual crowns of the columns, watch as we actual taper, and the crowns on the top adapt perfectly to our actual taper. Okay. Okay, well at this point everything is looking good. Oh, one more thing that we can do too if we want to while we're here. Remember that our project node is still available to us. And we can still come in here and adjust even the actual coverage of the grooves. So if we wanted the grooves to be covered a little bit less, or maybe we wanted them to be just a little bit less thin, a little bit more thin, we can still do, we can even do that right now, and everything still works as we do that. Okay. Very awesome. All right, I like to generally close my networks with just a null node, and it's a node that really does nothing, but it allows me just to put a node that is kind of like my final output node, and I like to color them blue, so in that way I know very easily where my final node is. Okay, so there is our little network, and just to recap, there is our tube, which we actually carve a slice from. Then slice is basically a 1 divided by the number of columns. We then create our little shape, the little groove shape that goes here by actually grabbing a circle and then grabbing a line and actually merging them together and joining them together to make this little shape. We mirror and join the shape on the left and left and right and up and down to get this actual shape right here. And then we use that to then use the project sub to actually project that into the U and V coordinates of the actual slice. Okay. We then use the trim sub to actually trim a hole inside of the actual patch, and then we also convert and then at this point we convert these to polygons. Okay. We use facet to clean any straggler points. Okay. Looks like that one straggler point disappeared, which is good, probably because of some changes that I did on the actual on the top. And then we use a divide sub to get the actual circle inside of the actual hole, okay, or trim surface, if you will. And then we blast the outer part so that we have it, and then we extrude it inwards to actually create a little groove that we see here. Okay. We finally merge those together to get a little groove slice, and we copy it in a circle to actually create our column. And the copy goes, we copy with number of copies matches the number of spans, and the rotate value is 360 divided by the number of spans, because basically we want a fraction of the actual full 360 rotation. Okay. Once we do that, we fuse them together. We fuse all the slices together so they don't have like hard edges in between. We also merge the tops and the bottoms, which we actually modeled using our extrudes and also using our curves right here. And last but not least, we create normals. Based on the actual angle, we give hard edges or soft edges. And we finally finished or tool, okay, or actual model. Okay, fantastic. Okay, this is probably sufficient for now. On the next class, we'll be looking into how to actually make a tool out of these things by packaging a digital asset, one of the most amazing and powerful features inside of Houdini. Thank you for watching, and have a good one.